Good afternoon, this is Schweitzer and we're going to do a quick little video on how to do electron configurations and then orbital diagrams. We may not do all of them, we'll do a bunch of them here. So nitrogen, if it's neutral, contains, let's go to our periodic table here, by nitrogen, and it contains 7 protons and 7 electrons. Now the mass number is 14 here. That's the protons and the neutrons. So we're just doing electron 7. Okay, well, let's go back here. So it's going to be 1, let's get that a little bit thinner. Okay, 1s, 2, 2s, 2, 2p, and of course we're looking to get 2p, and then so that's the 1s2, 2s2, 2p, 1, 2, 3, 2p3, and there we go. So I'm using in that method there the fact that we have certain zones in our periodic table which are my S blocks, my D block, and my P block, and they just build up. So that's the electron configuration. We can flip an electron configuration over to an orbital diagram. There we go. And this is really just giving the answers. There's 2, each arrow represents an electron. This guy's got 3 suborbitals. So 1, 2, 3. And I'm following right here Hund's rule. Hund's rule. Okay, so let's go ahead and let's do sulfur here. Okay, now sulfur's got, oops, wrong one, there we go. Sulfur's got, if it's neutral, 16 electrons. Okay, so let's do that. 1, and it's going to end in, see, sulfur is going to end in a 3p4. Third energy level, P block 4th. It's going to end in there. So I'm going to do the 1s2 and start working my way through. Okay, so 1s2, 2s2, 2p6, 3s2, 3p4. Okay, and then each arrow represents an electron. This one's full. This one's full. This one's very close to being full, but has 1 matched up. Okay. Other ones here we might want to look at. Okay. Anything else here? Define Hund's rule. Okay, so electrons will fill individual energy levels first before matching up. And it really becomes an energy thing. The energy wise, this guy right here, energy wise, this is lower energy than this would be. Okay. Pole exclusion principle. Take a look on the internet for that. Give you a world look at that. A little small little thing there. I'm going to do, let's just one more here, copper. Okay, I'm just going to do electron configuration of this one. 1s2, 2s2, 2p6, 3s2, 2, 3p6. So I've now gone beyond my last one. So I'm actually at this point, I am at argon. And I want to get to copper right here. That should end in the 4th energy level, copper. But this is a 3D range. So let's go ahead and let's, right, 4s2, 3, now remember the D block, I'm offset by 1, 3d, And how many do I need? Let's count them up here. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. So let's put 9 there, and that's that guy. Okay. So I think that's what here. You do one energy level, one suborbital, 3 suborbitals, 1 suborbital, 3 suborbitals, 1 suborbital, and 5 suborbitals for the D. And if you want to see the full details left, then you can, well actually, let's show one more thing here because we're here, okay? I'm going to do the shorthand for this guy. It seems those two seem pretty long. Shorthand for this one and the shorthand for that one. So for the shorthand for this one, it's going to be iodine. And then you use, rather than building from the beginning, we build from the previous noble gas. For iodine, its previous noble gas is krypton, right here. So, okay, so krypton. So I do is I take krypton, I put it in brackets, like that, and then rather than building from the beginning, I build after krypton. So krypton starts here, and I'm going to work my way across to iodine right here. All the way across here to get to iodine. Well, this guy right here, where do I start? What's the S block? So it's 1, 2, 3, 4, 5 S. Put that on there. So it's 5S2. This would actually be the configuration for strontium. D block's offset by 1, so 4D10 would bring me to cadmium. 4D10 would bring me to cadmium. Come on, buddy, get over. All right, 4D10. And then I want to get my last little bit. I mean, the P block would be, it's in the, what would it be in the, still the 1, 2, 3, 4, 5th row, so 5P5. 1, 2, 3, 4, 5. And that gets us our configuration for 5P5. If I want to flip this configuration over to an orbital diagram, simply add the suborbitals and add the appropriate arrows. 5 and then P, 1, 2, 3. So we do this one, maybe you could put it over here and do a shorthand method. Check your, always check, pause in the video to check out the answers, but you can check the PDF for the complete answer key if you'd like. Thank you very much.